Hey everyone, hope you're all doing well. Just want to touch on a few things before we get started with this video, going over the free response questions you were assigned. First of all, um, you guys are doing great. I really appreciate all the hard work, all the responses in the Google form. The progress check looks like it went pretty well. I posted the video. Hopefully you watched that to get things clarified. Then it seems like some people are having trouble viewing the webinar on the College Board website. I'm gonna have to try to find another way to get that to you guys since that was some important information. And then next was the Google form. Some of you had some questions for me. Just want to touch on a couple of those that were the main things. First of all, looks like most of you are pretty happy with what we're doing so far. Mixture of free response and then progress checks, and then some videos here and there, kind of reviewing. I try to do a bit of review as we do free response questions, kind of reminding you what to think about and what to look for. And then it looks like some certain topics you guys are asking to review, maybe use substitution, and a couple other things. And then finally, some ways we're going to be able to do some summative points. We might have some small quizzes online. It's a little tricky with math. I mean, we don't have any new content to cover, so it would be all review. Another one that we've done in the past when we need some summative points that are worthwhile for both you and for me are the Flipgrid assignments that we did it with multiple choice. This time it'd probably be with a part of a free response question. Be beneficial for all of us, and just some ways to get you guys some summative points there. But I will keep you updated as the weeks go by and try to keep things mixed up. I have some ideas, things to come up that might kind of mix it up a little bit. So let's get into the free response questions you guys were assigned that were due Tuesday night. All right, number 2, when a grocery store opens, it has 50 pounds of bananas on its display table. Customers remove bananas at a rate of F of T and add bananas at a rate of G of T. So these are rates, and the units would be pounds per hour. So we skipped part A. For part B, if you want to find F prime of 7, this would be a calculator question. So you would type in, you could find the derivative and plug in 7. And you should have gotten, looking at the scoring rubric, you should have gotten negative 8.120 or negative 8.119. And remember, since f was a rate function, then f prime is going to be the rate at which that rate function is changing. So when they want the meaning here, you need to think about, okay, at 7 hours, the rate at which bananas are being removed is decreasing by 8.120 or 8.119 pounds per hour per hour. Since F was in pounds per hour, F prime would be pounds per hour per hour. So hopefully you got the meaning correct there. Part C is the number of pounds of bananas on the display table increasing or decreasing at t equals 5. So check your answer first of all. The number of pounds of bananas is decreasing at t equals 5. So this kind of goes back to that the bathtub problem. We talked about the rate at which the water is filling the bathtub and the rate at which the water is leaving the bathtub. You know, the faucet's on and the drain's pulled and so forth. And that's kind of our analogy here. So when we see a problem like this, we don't get confused with all the ln's and the sines and the all that kind of stuff. Just think about it. If the number of pounds of bananas on the table is increasing, then the rate being added is more than the rate leaving, and vice versa for decreasing. So the rate being added is G. So we need to compare F of 5 to G of 5, or vice versa. It doesn't matter which way you look at it. As you find these in the calculator, you'll find that since G of 5 minus F of 5 was negative, that means F must have been more than G. And so the rate being removed was more than the rate being added. And so the number of pounds of bananas on the table is decreasing at 5. So check your answers for those. Give yourself points based on the rubric, and we'll go on to number 3. All right, for number 3, I'm going to go ahead and scroll down so you guys can check the scoring rubric first before we start going over it. Go ahead and pause the video and check your work there. All right, and then scrolling down to catch the rest of part D. All right, so we've seen problems like this before, and this is, a fundamental theorem of calculus type question where you're relating f prime and f double prime, and I will not get to see the test before you guys, but if I were to ask just 2 free response questions, this topic, obviously being the fundamental theorem of calculus, would be pretty high on my list. So make sure as we go over these, you're checking your work carefully. You're trying to figure out what's going on here. Look for extra resources if you're still confused. Email me if you're still confused, and I'll do my best to explain as we go. All right, so we're looking at the graph of f prime, and we're going to be asked about f, and we're going to be asked about f double prime. And so as we read the problem, the function f is differentiable in the closed interval from -6 to 5 and satisfies f of -2 is 7. That's going to be important for us. The graph of f prime, the derivative of f, consists of a semicircle and 3 line segments as shown in the figure above. And so as we think about f would be the area function here. If f prime is the graph we're looking at, f of x is going to be the integral from some value to t is just our dummy variable of f prime of x dx. And if you remember, we did do that, I think it was worksheet 5 we called it, where we did a variety of, trying to write f as an integral setup of some sort. And if you remember correctly, -2 here is our important reference point. It's kind of our starting point to base everything else off of. Since we know a point on f, we need to use that point to evaluate f at different points. And so we put -2 as our lower bound. And just to check it, to check f of -2, if I were to plug in -2 in here for x, f of -2 right now would be the integral from -2 to -2. That's 0. We don't want it to be 0, we want it to be 7. And so if we add 7 here, we have a nice way to write f of x that we can evaluate other values for. And so look back to that worksheet if that's still confusing to you, and hopefully that it makes sense so we can move on. So to find values of f of -6, well, remember, we're starting here, our reference point is -2, and f of -2 is 7. So we have a value of 7 there. F of -6 is going to be the integral from -2 to -6 under f prime of x dx plus 7. And so right away you should be thinking, okay, -2 to -6, that's backwards. And so whatever value I would actually think about as an area here from -6 to -2, it's going to be treated as the opposite of that. And so the base is 1, 2, 3, 4. The height is 2. Half of 2 times 4 is 4. And so this value, this part here, is actually -4 because it's not the integral from -6 to -2. It's the integral from -2 to -6 backwards. Plus 7 gives us a value of 3 for f of -6. And then f of 5 is the integral from -2 to 5 under f prime of x dx plus 7. And now if we go from -2 to 5, we are working left to right. 1, 2, 3, 4, 5. And so now we're going to have a proper integral. -2 to 5 is fine. So if I find this semicircular area, it's actually going to be treated as negative. When I find this triangular area, it's actually going to be treated as positive. And I'll add 7 to it. So 7 minus this area plus this area would give me my f of 5 value. And so this is a semicircle with a radius of 2. So pi times 2 squared would be the whole circle. Take half of that. So this area is negative, well, it's 2 pi, but it's below the x-axis, so it's negative 2 pi. So we have this part is going to be, I also need to find the value of this triangle. The base is 1, 2, 3. The height is 2. Half of 2 times 3 is 3. And so the shaded part from in blue here is negative 2 pi plus 3, and then plus the 7 we started with. And so we get 10 minus 2 pi. So 10 minus 2 pi is what f of 5 is. And there's 3 points for that. Part B, on what intervals is f increasing? So for where f is increasing, we need to look for where f prime is positive. Remember, f prime is positive, makes f increase. And I can just look at the graph and tell that f prime is positive from negative 6 to negative 2, and then from positive 2 to 5. They had brackets on those. They would also accept parentheses there. All right, for part C, find the absolute minimum value of f on the closed interval. So we need to consider endpoints of negative 6 and 5. We also need to consider critical values of negative 2 and positive 2, and find the values at each of those. And so we've kind of done most of that work already. And so it's just a matter of lining all those up and comparing them here. And you'll see that the absolute minimum occurs at f of 2, which is 7 minus 2 pi. And then for part D, for each of f double prime of negative 5 and f double prime of 3, find the value or explain why it does not exist. So if I look up here at the graph of f prime, if I were to say what's at negative 5, here's negative 5. F prime of negative 5 would be the height here. F double prime of negative 5 would be the slope there, which looks like a negative slope. And so really just a simple secant slope formula will give me the slope of that line. So I go down 2 and write 1, 2, 3, 4. And negative 2 over 4 is negative 1/2. So f double prime of negative 5 is negative 1/2. And then the next one they ask us for is f double prime of 3. So 1, 2, 3. F double prime of 3 is not going to exist. I think you remember it's sharp here, but you need to have some sort of mathematical explanation. What I would recommend doing is showing that you could say the left hand derivative at x equals 3 is, and then find the slope of that segment. The right hand derivative at x equals 3, and then find the slope of that secant, that little segment there, is blank. And then say the left-hand derivative does not equal the right-hand derivative, therefore there's no f double prime of 3 does not exist. As we practice more mathematical notation, they would like to see you, I think they would accept the left-hand derivative, right-hand derivative there. However, if you want to get into some more mathematical notation here, you have actually the left hand, and then you have a derivative setup is 2, and then the right-hand derivative setup is negative 1, and then you just show that those are not equal. This would be the perfect answer. Of course, our answers aren't always perfect, but they can still be correct and get full credit. So some sort of description, finding the value for f double prime of negative 5, telling why f double prime of 3 does not exist, and then explain that the slopes from the left and the right are different. All right, I hope that explanation made sense for those free response questions. We'll continue to do this more to come, and please check this video will be posted for Wednesday's content, and then check your email daily, as I might need to send some things if assignments aren't submitted correctly. But new content will still continue to be posted on Mondays and Wednesdays, and the office hours have been updated a little bit. They haven't changed too much, just they've been shortened a little bit to try to help some connectivity issues. So feel free to email me with any questions, and I hope you guys have a great day.